All right, my lovely viewers, welcome to Frank Teaches MLOps. Yeah, guys, yeah. So today we will be looking at something very important into our journey into um machine learning operations. All right, and and that is pandas um Pandas series. All right. But before we go into talking about Pandas series, all right, let me reiterate. I want to what? Reiterate. So let's call it, the topic will be Pandas series in 30 minutes. 30 minutes, guys. Pandas series in 30 minutes. That's the topic. Pandas series. So I want to reiterate. All right. So we have data science, right? And we have machine learning. So there's a thin line, there's an overlap. Let me not say thin line. There is an overlap between data science and machine learning, a very large overlap. Let's say this is the same size as this. Great. Now, here is the overlap. On data science, all right, you'll be doing things like you'll be using tools like NumPy, Pandas, right? Uh-huh. Matplots, Lib, Matplotlib, Seaborn, etc. That's on data science. This is what you have on data science. Now, machine learning, all right, you now start using different libraries, scikit-learn, scikit-learn, all right, can call it sklearn, scikit-learn, all right, um, um, algorithms, XGBoost, right, PCA, principal component analysis, PCA, principal component analysis. I think this should be under data science as well, right? So there is an overlap. So in here, you're still using these guys. You're still using these guys, right? So that is, so I would say the difference between data science and machine learning is very thin. It's a very thin line because there's always an overlap. A data scientist can become a machine learning engineer. So this is where everything started from, right? So from data science, you can easily become what? A machine learning engineer, right? So take note, guys. Let me keep this at the side. Now, let's get started with our what? Panda series in 30 minutes, right? So before we go ahead talking about Panda series, what exactly is pandas? Pandas. What exactly is pandas? I hope I'm still recording great. Okay, so pandas, by definition, right, is a kind of a Python library, right? That's okay, let me like is a what? It's a Python library, uh-huh, that is designed to work, all right, on okay, on I would say first, okay, on to work on, I would say data frames, all right, data frames that have relational data, right? They have relational data, right? Or labeled data, right? Or labeled data. So similarly, we could say that um, um, pandas, pandas, right? Um, um, could be used, right, for for data manipulation, right? Data manipulation, uh, operating on data sets, operating on data sets, right? Um, performing performing exploratory data, right? Sorry, exploratory analysis, performing exploratory analysis, right? And and machine learning related tasks, right? So these are things that one could use pandas for, all right? Pandas for, right? So now these now gives us now boils down to the application of pandas. Where is pandas applied? Where is it applicable, right? How do you apply pandas? You can apply pandas in different ways. You can apply pandas in data cleaning. Like you said on this definition, right? It is used to manipulate data. That's what a panda does. It's used to what? Manipulate data, right? So for manipulating data, right, is the its application is in what? Data cleaning, data preparation, data data pre preparation, data exploration, data exploration, right? Data analysis, data analysis, and data visualization, data visualization, and a whole lot. And in performing machine learning task, right? Etc. etc. So you can apply pandas in a whole diverse area in as much as it is for what? Manipulating what? Data. In as much it is for manipulating data. Now the next phase is how to install pandas. Installing pandas. So installing pandas is very straightforward. So you can come here and say how to install pandas. Like we earlier said, pandas is a Python library, right? Right? That is designed to work for manipulating what? Data, right? So simple. So if you go to your Jupyter notebook, right, all you need to use pip install pandas. Pandas, that's the library name. So if I hit enter, right, it's going to install it. But however, I already have it already. So I already have what? Pandas already. But this is how to get pandas installed within your Python environment, or if you're using what? Jupyter notebook. Okay, great guys, great. Now how do you use pandas? Now to use pandas, right? How to use pandas? After installing this, so we install this by running what? Pip install pandas. Now, how do you use pandas? I will say how to import pandas. How to import pandas. So you import pandas by running this. Import pandas. That's it. Similarly, you can create an alias for pandas, because using pandas as a keyword is too long, right? You can say import pandas as pd. So PD in this context a an alias, all right? In place of pandas, I'm using what? PD. So that's the main. So let's get started, guys. All right, I can say import pandas as what? As PD, and I will run the cell. So I've run the cell. So now PD is now available for any other operations I'll perform in my Jupyter notebook. All right, in my Jupyter notebook. So now the next topic we have is pandas data structure. Pandas data structure. Copy this. Pandas data structure. Pandas data structure. Right. So data structure is a way data is arranged. Right. The way that is arranged. And basically, in Panda, there are two major data structure. One is a Pandas series. Call it Pandas series. Right? A Pandas series. And the other is a Pandas data frame. Call it Pandas data what? Frame. Okay. Now, today topic is about Pandas what series. Okay, Pandas series in 30 minutes. So, what is Pandas series? And I'll just throw a shady light on Pandas data frame. I'm not going to detail about data frame because this should be topic for another day, right? Let me just talk on what Pandas series. So, Pandas series, what is it all about? So, Pandas series a series, right, is a one-dimensional, right? One dimensional, I can call it 1D, right? It's a one-dimensional labeled array, labeled array, right? That can hold any data type, right? Right? Can hold any data type such as such as integer, integer, string, float, etc., etc. Boolean, bool, etc. All right, great guys, great. So this is what a series, and we're going to show us how a series looks like. And in the context of a a panda is the opposite of a series. While a series is a one-dimensional labeled array, a data frame is a two-dimensional what? Data array. So we can come here and say a data frame is a what? Two-dimensional, right? Labeled array. All right. So a data frame also um, um, could be used to represent data, right? Could be used to represent data in tabular form. In what? In a tabular form or a tabular data structure, right? So this is the purpose of what data frame, right? AKA it arranges or represents data in what? In rows and what? Columns, right? So data frame is a two-dimensional label array that represents data in what? Tabular form. So we won't be talking about data frame today in today's video, right? So we'll only be talking about pandas series. Now that now leads us to what? Creating pandas series, right? How do you create a panda series? Let's get started, guys. Creating what? Pandas what? Series. Simple, guys. Simple. So we're going to be creating pandas series from different um um, Python data types, all right? Python data types. But before we do that, right, um, um, we are going to structure, show us the syntax, right? Let me call this pandas series syntax. What to follow, right? Syntax. Let me run this as a markdown. Okay, Pandas series syntax. So Pandas series syntax is, I'll call the alias pandas alias. I could say pandas. I'm using the keyword pandas, but because of I've created an alias called PD, right? So I I won't call pandas. I'll just say pandas alias. All right. So let's say this is syntax. Pandas alias dot series. The series is a method. All right. Now, pandas series accepts multiple parameters. It accepts the data, it accepts the index, right? It accepts index, right? It also accepts the data type, right? And it also accepts a name, and it accepts copy, right? Now, data type, name, and copy, these are optional, and even index is optional, right? By default, it uses um, a numeric index, right? It uses what? A numeric index, right? Now by default, okay. And but data is very important. It's very paramount, right? Is an important parameter for what? For series. So this is, let me convert this to markdown. So this is how you you defined a series. Oh, sorry. Let me remove this from markdown, please. Remove it from markdown. Back to code. All right. So okay. So that is Pandas series what syntax. Now let's create a series from a list, right? So I have my L, which is list. So an irregular Python list, all right? A regular Python list could be based on strings, all right? So let me just create, let me just say name, okay, let me just say orange, orange, apple, guava, and pineapple, pineapple. I hope I got the spelling correctly. Pineapple, pineapple. I hope I got this correctly. All right. So this is a regular list. All right. So I run the cell, and if I execute that, I have a list, right? So I can pass this as a series. So I can use this a list to create a series. I can say um, um, PD, which is the pandas alias dot, sorry, dot, all right, dot what, dot series into my data. My data is what? L. That is L. Remember, it will automatically what? Assign an index, right? So if I run that cell, sorry, if I run this cell, it automatically what? Assigns a what? A numeric index. So the first item is that orange, apple, guava, pineapple. Even when I didn't specify an index, all right? Now, if I come here and let's say, let's specify the index. So let me use I as my index. I is my index. I want to use a a okay, O for orange, A for apple, G for guava, P for pineapple, right? So now say okay, I'll create a list, a character list. So I'll say O should be indexed to orange, then A should be indexed to apple, then G should be indexed to guava, then P should be indexed to what? What's it called? Pineapple. So if I come here now and I say my data, I say something like this: data is equal to what? L, and index is equal to what? I. So if I run this, I should have this as my what? Index. You can see to have this word as my what? Index, right? So even if I don't say data is L, right, it should automatically what? Give me data as L, right? It should still run. But I have to what? Specify categorically, say my what? Index is the index value, which is this. Because if I don't do this, it automatically what? Assign this a what? An integer base index. An integer what? Base index. So since I have an index already, I have to categorically mention what? The index. So this is how you create a what? A panda series. So you can also create a panda series from a dictionary. So you can say a d, or can say dict is equal to. So let's create a dictionary of profile, someone's profile, biodata. Can say someone's name is Frank, right? And state of origin, state of origin, state of origin. So state underscore origin is rivers. Uh-huh. Um LGA, all right? LGA is Kana. Uh-huh. Then age, uh-huh. Age is can say age is 18. All right. So just simple dictionary. So I can use that to create a list. I can say PD dot series, and the data is what? DIT. And we have this. So name is Frank, state of origin is reverse, LG is this, age is that. So guys, this is how we create a what? A pandas series, right? Like I said, it's just a what? It's a one-dimensional. So if I come here and check, I'll come to the attributes. All right, I could say I can assign this to, let's say, s is that, right? Then what is s is this. So s dots n dimensional. So this is a method, or as is an attribute, right? It's an attribute of what? Of pandas series. So it tells me, it returns the dimension, right? The number, the array dimension of of the series, right? It tells me that it is a one-dimensional array. So series is a what? It's a one-dimensional labeled array, right? So we shall come to what? Series attributes. So now the next topic is, let's look at what? Series attribute of what? Of series. We could say pandas series attributes. So let me run this as a markdown. Good. All right. So we have a lot of attributes. So the first attribute, we have attribute of data type. Okay, we have index, it's an attribute. We also have values. All right, we have shape. Uh-huh. We have n dimension. Uh-huh. We also have size of the series. Then we have if a series is an empty series or not. So these are all attributes, right? Attribute of what? Panda series. So I don't want to run them. So let me create them as comments. Oh, I don't need all this though. All right, so I can just create a cell below. Great. Okay, so now let's create a series, an 8-row series. All right, 8 rows from a typical using NumPy. All right, so I can come here and say import NumPy as what MP. Right, so I have a video I did on NumPy, which is a NumPy in 60 minutes. So guys, if you've not watched that video, please kindly go and watch that video. NumPy in 60 minutes. If you've not watched, this is the highest, guys. All right, so this is the highest. NumPy in 60 minutes. It teaches you everything about NumPy. Right, so if you've not watched it, please hurry and go and watch it. Okay, great. So now here we are. Now I can say numpy.arrange. I'm creating an array element of 8 items, an array of 8 elements, right? So this 1 row, 8 column, 1 row, 8 column. So now I need to convert this. I can say this, let me assign this to S. So S is this, so I can now say S dot series pd dot what series of what S. It converts that as a series. All right, great. Now we can now start getting what the attributes. So I can say S dot data type. So the data type of this should be an integer, because these are numbers now. S is numbers. So come here, S. These are what? Numbers, right? So they are what? Integer. So the data type is what? Is int. Okay? The data type is what? Is int. Great. So if we were to dict, remember we created a dictionary what series. So if I now come here and say and do something like this, right? pd.series of what? Of dict. I have something like this, right? Now let's get the type. So I could say dot dot d type. So the d type, why is it giving me 0? All right, why is it giving me 0? D type. Okay, so I could or you need to give me as a series. Give me as a series. Okay, let me say D is that. All right, D is that, and what is D dot D type? The D dot D type tell me, okay, still tell me that. So which is dictionary. Sorry, which is the data type, which is also show me strings. All right, so it's a mixed, it's a mixed data type. So if I convert this age, to a string. All right, now this should give us what we want now. So let me come back here, rerun this and rerun this. We're still getting that. All right, let's continue, guys. Okay, great. So the next what's it called, attribute is index. So I'll come here and say dot index. Okay, okay, numpy series. So S in this case is okay. So it's saying that n-dimensional array S. Okay, so let me assign this to a series. Let's say SS. So SS is this, SS is this, and SS the series. So SS the series, this is the index. All right. So this is now index, but this was an array. All right. This was an array. Okay. So it tells me that the range index is start item is 0, stop item is 8, step value is 1. So what it means is that it starts from 0 to what, to the 8th item. 1, 0 is counted as 1, 1, 2, 3, 4, 5, 6, 7, 8. So start item is 8, end item is 1, 7, right? So stop item is 8, right? And the step. So the difference between 0 and 1 is 1. 1 and 2 is 1. 2 and 3 is 1. So that's the step function, right? The step value. Great. So can I say ss dot the next that was index values dot values next attributes. So these are the values. It displays the elements of that array, right? The original values. You can see the values of the what of the series. Okay, and you can also check the shape. What is the shape of the series? The shape should give us shape should give us 8. The size of this shape, the shape is 8, and the size is also should be around 8. Okay, okay, so the shape returns a tuple. I think it returns a tuple, a Python data type, returns a tuple, while the size returns an integer, right? Size. And is this series empty? It false. It returns a boolean, right? It returns what? A boolean. Great. So these are pandas series attributes. Okay. Now pandas that comes also. We also have what? Pandas series methods. Different methods. Let's say for instance now, this pandas series methods, right? Let me run this as a markdown. Here we go. Good. Now there are different methods. We have the head function. We have the head function. We have the tail function. We have the info function, right? Then we have the what? Describe what function. So these are methods one could apply to what? Pandas series. Let's start applying. So ss is what? Ss is a series, right? So from here I want to head. What head will do is head will display, all right, the first, by default, the first five rows of a series. Dot head. I said dot head, it displays by default the first five. You can see outside this I have 8 rows, right? I have 8 rows, but if I need to display the first 5 rows, I use what? Head. Now if I need to display the first 2, I can pass an integer value, right? That's why you see this n here, right? Can pass an integer value ss dot 2 head dot 2 head into 2 displays the first 2 rows, right? 0 and 1. These are the first 2 rows. So if I need the first 4 rows, the first 4 rows, guys. First 4 rows. I got that, right? So and so on and so forth. So we also have the tail. So ss dot tail, it displays the last 5 rows. Can see now the last 5 rows from 3 to 7. So if I want to display just only the last 2 rows, I'll say 2, 6 and 7, etc., etc. Now info, ss.info doesn't pass any parameter, tells me information about the series, the Pandas series. It says that this is a Pandas core series. The index is 8 entries, 0 to 7. Series name, there's no series name for it. This is the 8 non, blah 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 blah. And the data type is what? An integer of base what? 64. That's the information about what? The series. Now let's describe the series. You can say ss.describe. So describe also does not accept any what? Parameter. So describe says the count is 8, the mean of those values is 3.5, and the standard deviation is 2.4. The minimum value there is 0. The 25 percentile is this, 50 percentile is this, 75 percentile is this, and the maximum value in that range in this distribution is what? Is 7, right? So this is what the description to what? To the series. So these are I would say methods of Pandas series. Now that being said, the next item on our list is um, indexing in Pandas series, right? Indexing in what? Pandas Pandas series. Pandas series. So that we could say types of indexing, right? So type of indexing we have in Pandas series. Let me convert this to a markdown, right? So there are different in there are three major indexing. One, we have the label based indexing with lock. So there's a function, right? There's a keyword called LOC. LOC means location, right? Now, for performing label-based indexing, we are going to use a keyword called what? Lock, right? So it's applicable to label-based. I'll show us label-based indexing and integer-based indexing. So the next is integer position-based indexing with iLock. So the I there is integer what? Location. Then finally is indexing with brackets. So this is a common way of indexing with brackets, all right? So I'm not going to run the cell. So let's look at the different indexing: label based, integer index. So we have SS. SS is this, right? Great. So everything here, this index, this value you're seeing here is index, right? So this is integer base, right? This is integer base. So if I try to use what's it called, LOC, I'll get some errors. So if I say SS dot LOC, LOC of what? So it's supposed to be a label. A label is kind of a string, right? I'll have an error because there is no label base, there's no label base but index, right? So for me to get this index value, I'll use my what? Integer base, integer position. So it tells me the position of this item, of a zero item. So this zero index, what is the position? Is at position 0, right? Now if I look at okay, let's change these values, right? Let's change them. Let me use yeah, what was it defined? SS, right? NumPy array. So I can come here and say this is a arrange um multiples of 2, right? So let me I'll come in a step value of, okay, from 0, I'm printing a range of integer from 0 to 30. Let me not say 30. 0 to 26, all right, a step value of 3, all right? So I have 1 2 3 4 5 6 7 8. 8 times 24, 25. 2 3 4 5 6 7 8. All right, so 24. I have that. 1 2 3 4 5 6 7 8, right? So now this now makes sense. We have the value now from 0 to what? 21. Okay, so this now makes sense. Now makes some real sense, right? Makes some real sense. Great. All right, so let's jump to describe. Let's now jump to here now. So SS, we have this value in SS. So the position of 0, let's say position of 1, index, right? We have it as 3. What's the value of, what's the index value? What this means is that the index value of 1, the index is 1, 0, 1, 1. What's the value? The value is 3. So that's why I'm getting what? The 3, right? So the index value of 7, what was it? Is what? Is 21. 21. All right. So this is integer position based indexing with what? With the use of what? iLock, right? iLock. Now let's now recreate a new a new series based on labels. So I have my label. My label is A, B, C, D, E, F, G, H. All right. So this is my label, right? And I have my data as SS, right? So I'll now say PD dot series, P dot series. My data is SS. Then my index is what? Is my label, is my label, right? So if I run this, I have bam 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 bam. Uh, mm, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Boom, 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 boom. Why am I getting this? Um, why do I have this? 1 second, guys. Why am I getting this? It's supposed to give me now. Okay, let's do something. Mm, mm, okay, let me say um okay, let me create a dictionary out of this. All right, so my label is a dictionary. The value is, let's say, 20, could be 5, 10, 15, 20, 25, 30, 35, 40, right? So let's call this LA. So LA is my data. My data is a what? It's a dictionary, right? So I'll come here, series LA. So I'm sorry, I've not run this cell and run that. So we have this. So this is, we're going to perform label based indexing. So you can see this is a label based indexing. So what I'll do to now start getting each of these items. So let me assign these to L, right? L to a variable. So this now. So if you want to grab these values of this label based index, so I'll say L dot what? LOC, right? So LOC, label based, this is label based indexing with what? LOC. So LOC, I need what? The item at index A. I have 5. All right. So LOC, I need the item at index E. I have this, right? So can I have E and D? I have an error. So what I'll do is I'll use slicing instead. So slicing gives me E and D. All right. So let's do it like this. Bam bam bam. Okay. This and this, because they are two different index. All right. So I have that value. So it's not giving me anything. So I can say a range A B C D from, oh sorry, I'm doing the opposite. So it's supposed to be D to E, D to E. So D to E, I have this. All right. So I have items. So index values for D and E. So D is 20 and E is what? 25. So if I need a range, I can say print from index from A to D. I can say A to E. Can see, right? I can also get from E to the last item, to the last index. All right, this gives me from E to H, from E down to what? To H. So this is what we call slicing. I did some level of slicing in my what NumPy. So that's why I said it's very important, very paramount to go and watch my video on what NumPy. So if you've not watched it, guys, you're missing out. Go and watch the video. Then that was label based. So this is how label based indexing works in Pandas series. Then the last is indexing with brackets. All right, so I can just say indexing with brackets. I can say L of A. I have that. All right, so L of A to E. I can have that. Right. So this indexing with the brackets is more like the LOC. All right, but maybe they have their application somehow, right? The difference is somehow. Okay, so similarly I have my SS. So I have my SS, sorry, um my SS is this, SS is that. So I can say SS brackets. I need the value at index 6. The value at index 6 is what is 18. Can see that. So these are the different indexing you can perform on what Pandas series, right? Now we now move to arithmetic operations, all right, mathematical operations in Pandas series. So we have mathematical operations in what pandas in Pandas what series, right? Convert this to a markdown, and there we go. Okay, so we can perform addition, subtraction, multiplication. So let's take a series. So this is this, right? So I can add, perform addition. So if I say plus 2, it gives me 2 5 this, it adds 2 to what, to my data. So this is my original data. So SS plus 2, I have this. Okay, SS minus 2, I have that. All right, SS multiply by 2, I have all of that. SS divide by 2, I have all of these. SS um floor 2, I have this. That's divide by 2, that's any remainder. SS modulus 2, I have this, etc, etc. Okay, so these are the different mathematical or arithmetic operations you could perform on what Pandas series. All right, also you can combine two pandas, you can combine two series. Okay, you can say, okay, this is SS is one series, then L, all right, L is another series. So if I say L is this and SS is that, right? So I can say L plus SS. Let me see if this will fly. So it's giving me, because they are of two different uh data type entirely. So if LA LA is a series with labeled index, right? While SS SS is with integer index. So let's now do something. Let's create another series, all right? PD dot series. Okay, let's say numpy dot arrange, right? I need 8 items. That's it. So S is this, right? So this we can add SS and S. I can say S plus SS. It should give us, because they are of the same index, right? They have same index. It's integer and this integer. So this will fly. I can say S times SS. So multiply all the items in the two different indexes, right? So these are ways of you can perform arithmetic operations on what, on your series, on two different series. Okay, I can say modulus, you have that, etc, etc, right? Then the last but not the least is you can convert series from one object to the other. All right. So let's say I have my SS. My S is this. So I can convert this to a list. I can say s dot to underscore list. So it's a function, sorry, man. It's a method, right? That's convert this to a normal Python list. So if I assign this to PL, right? Then what's the value of PL? PL is what? It's a Python list. It's a Python list, right? So I can also convert this to, let's say, convert this to a string. String PL is now a string. I can convert this to a tuple. Tuple, oh, sorry, does not have any attribute tuple. Okay, so let's see, can convert it to objects, to a data frame. So data frame, I can say frame and run this. So you can see that's represented my list, my series as a what? As a table, a data frame. So with these guys, you can see, okay, I didn't mention this part. Sorry, apologies. This will be um converting series, converting series to other objects, right? So as a markdown, great. Let's run that. Great. um Great. So can convert it to list, can convert it to string. Can convert it to data frame, can convert it to NumPy array, to NumPy, so etc. So we've seen frame, we've also seen list. Let's look at we saw list, we saw list. This was list. Let me just remove this PL, it's wasting my time. This was list, can convert it to string. That was string, can convert it to frame. That's frame. Can also convert it to what? To NumPy array. So this is it, guys. We can convert it to values. No, that was attributes. Values is attributes, right? So this is everything about Pandas series. All right, Pandas series. So my lovely viewers, at this juncture, all right, we are going to stop here, right? We're going to stop there. So this is Pandas series in 30 minutes. All right. So in the next video, we shall look at Pandas data frame. All right. So Pandas data frame. Until then, I want to say bye bye and have a lovely weekend. Peace out. Thank you. Thank you, guys. Thank you.